This is the year 12 mid-course exam. We're looking at paper 2. We're in question 5. These are the extended responses. We're now on section C, and as you can see from the number of marks allocated, this is the larger and more extended response. Let's take a look. So explain. So with explain, we're looking to describe, and we're looking for a reason why, some theoretical reasoning, and it's to do with the hydrophobic and hydrophilic properties that contribute to the arrangement of the molecules in the membrane. Now, I'm sure you're already thinking about what the arrangement of the molecules in the membranes are, but let's begin our answer by stating or giving definitions of hydrophobic and hydrophilic. So I'm going to map out what needs to be done rather than writing a perfectly presentable answer. So these are the component parts you should be hitting. Hydrophobic, you need to say that it's water repelling. Non-polar is okay. Whereas hydrophilic is water attracting. And also acceptable is the statement of being polar. Okay, so that's our first part. Now we need to address the arrangement of molecules in the membrane. So that's one. Let's move on to 2. I think the second major point is to remind your reader that cells live in water. All cells live in water one way or another, and indeed their cytoplasm is water, and yet the membrane sits between the two as a barrier. So how is this organized? So if we make this the outside and this is the inside of the cell, then we have the arrangement of what you no doubt will be calling phospholipid molecules. So that's going to attract some marks. Just give me a moment to draw this. So we have, excuse me just a moment while I get the rough idea in. Of course, you should be doing a much nicer job in your drawing than this. And what we're trying to show is that these individual molecules are called phospholipids. And the phospholipid has 2 parts. The head of the structure is hydrophobic. I'm just going to put H-phobic here. And the fatty acid tails in the center here are hydrophilic. And so the tails go together without any repulsion, and the heads of the molecules are out here in the water, in the cytoplasm of water. So that kind of works. The idea of the phosphates, hydrophobic, are in the water of the cytoplasm, and the phosphates on this side are in the water of the tissue fluid, or indeed the habitat, whereas the fatty acid tails come together in a hydrophobic layer like that. So I think probably by this stage, with the naming of these components, we're up to about 3 or 4 marks. What we then need to do is to develop the membrane structure to include the other components in it. Like, for instance, we might want to draw our diagram like this, the phospholipid bilayer again, and to introduce a transmembrane protein, an intrinsic protein embedded in the entire structure. Excuse my diagram, just trying to be quick. And what we would be pointing out is that on the outside here and here, the amino acids which make up this protein, they would have to be hydrophilic, water attracting. Whereas the section of the protein which is in the center of the membrane, this zone in here, well, that would have to be in here, would have to be hydrophobic, which is to say that the amino acids in that area would have non-polar, non-charged R groups, whereas the amino acids in here and here, their amino acids could be polar and charged. That's the R groups. Now we could extend this even further, so now I think we're probably up to around about 4 and 5 marks. Let's push on a little bit more. We could talk about this protein a little bit more, talking about the, for instance, if we take an aerial view of this from the outside and we look down on the protein like that, then the core, where the channel is, then the channel has to be lined with hydrophilic amino acids again, so that polar molecules, charged particles such as ions, can actually move through that channel. If we were looking at the membrane like this, another phospholipid layer, the drawing's getting worse. Yours, of course, needs to be good. Remember, we have proteins which sit entirely on the outside of the membrane, the peripheral proteins, and in this case, these peripheral proteins, they would be hydrophilic, or perhaps you might prefer to call them polar, that they don't take part in the central region of the cell membrane at all. So I think by now we're probably up to around about 6 and 7 marks. The more detail that you put in, the clearer that you label the structures. If you're using diagrams, the better. There are perhaps 1 or 2 additional points we could make. I'll just use those to finish this component of the essay, the extended response. Just put my fatty acid tails in like this. If we have a protein like so, and there were sugar residues, carbohydrate, then that would have to be polar or hydrophilic, like so. And then we could also remind ourselves that within the cell membrane structure, we often have cholesterol molecules. I'll just shade this like so. And the cholesterol molecule is, like the phospholipid, is amphipathic, is both positive and negative charges, and will sit and orientate itself in the membrane, so that if I just make a shape for the cholesterol molecule, the charged part of the cholesterol molecule would be with the phosphate heads like this, and the non-polar hydrophobic part of the cholesterol molecule would be with the tails. Not a very good diagram. That's the cholesterol molecule here. This is the hydrophilic region, the polar section, and this part here is the non-polar. I think that was more than enough to get the 7 marks for this particular section. End of paper 2.